Hello friends, if you have been writing the code for some times, you might face a problem like code becoming too complex, small changes breaking other features, difficult testing and maintenance. To solve this problem, software engineer follow a set of design principle called SOLID principle. SOLID is a collection of 5 object-oriented design principle that help developer write clean, scalable and maintainable code. So SOLID stand for S stand for single responsibility principle, O stand for open close principle, L stand for leaks or substitution principle, I stand for interface segregation principle, D stands for dependency inversion principle. So in this video, we will understand each principle using real life example along with the code example. So let's get started. So the first principle is single responsibility principle. A class should have only one reason to change, meaning a class should do only one job. Let's take the real life example. Think about a restaurant worker. Imagine one person is doing cooking, taking order, billing and cleaning. That would be chaotic. Instead, restaurant divide the responsibilities. Chef will do cooking, waiter will taking the orders, cashier will do billing. Each role has one responsibility. So let's see the code example. So here the problem is this class handle business logic, database logic, email logic, too many responsibility in the same class. So instead, how we can segregate this? Like you can see this example, code example. Now each class has one responsibilities. User service will only do a create user, user repository will save the user, and email service will send the email to the user. So let's see the next principle, open close principle. Software entities should be open for extension, closed for modification. Meaning you should be able to add a new behavior without changing the existing code. Let's see the real life example of this. Think about a mobile charger. You don't modify the phone every time you change the charger. Instead, extend the functionality using different adapter. So let's see the example of this. We can see this function is responsible for based on the customer type, it is returning the discount. So if new type appears, for example vip or corporate, we must modify the function again and again. So let's see how we can change the this code into good code. So we can see here I have one class which is discount, and I am extending things this discount class if new class is appears like for regular customer. I am extending the discounting. Now we can simply add VIP customer. As many other class we can add it and extend the discount class without modifying the existing code. Principle which is Liskov substitution principle. In this, object of subclass should be able to replace object of parent class without breaking the application. So let's understand this uh, by taking the real life example. Imagine a bird class. All birds should be able to fly, right? But penguin cannot fly. So if our system assume every bird can fly, it will break. So let's see this example. If we replace the bird with a penguin, then our system will break. So how we can convert this code into a good code by using this principle. So now the design correctly represent the reality. So I will create a bird class, and I will create one more class which is flying bird, which is extending the bird class, and I will create a method in that flying bird mm, class which is fly method. So whenever the new class I will create, I will just extend the flying bird, and if I will create a new class which is playing with, that will extend the bird without flying function. So let's see the next principle, which is interface segregation principle. So in this, client should not be forced to dependent on interface that do not use, meaning smaller interface are better than the larger one. So let's see the real life example of this. Imagine multifunctional printer. It has print, scan and fax, but a simpler home printable. Let's see the real life example of this principle. Imagine a multifunctional printer. It has print, scan, fax, but simple home printer only needs prints. Forcing it to implement scan and fax makes no sense, right? Let's see the code here. I have one interface which is machine and which contain three functions. A simple printer must implement all the method, which is not right. So let's see the good example of this. Now device implement only what they need, right? So uh, so this is the good example of this principle. So now let's see the next principle, which is dependency inversion principle. So high level models should not depend on low level models. Both should depend on abstractions. So let's understand this by using real life example. Think about wall socket. Different devices, phone charger, laptop charger, and TV, all connected to the same socket interface. Device depends on interface, not the electricity source directly. So let's see the code example of this principle. So here we can see user service depends directly on the MySQL. Okay, so let's see how we can change this code into the good code by using this principle. Now we can see in this code MySQL, MongoDB, Postgres without changing the user service. We can use any database by segregating the code by using this principle. So these principles are widely used in framework like this is about the solving principle. So these principles are widely used in framework like Spring Boot, Spring Framework, Angular, React. If you enjoy this video, don't forget to like and subscribe. See you in the next video.